Okie doke. Today we're going to continue yesterday's lesson. Let me zoom in so we can see a little better. Yesterday we started talking about the real number system. Today we're just going to go through a few more examples before we start on our assignments. Let me get something to write with. We are being asked to list all of the number sets to which each number belongs, and then we're going to circle the most specific set. I have the number 12 pi here. I know that pi is irrational. That means the decimal is non-terminating and non-repeating. If we multiply a number that has two decimals by something, the product will also have two decimals. If I were to multiply a number that has 32 decimals by 12, the product would also have 32 decimals. So think about what happens when we multiply something that has decimals forever because it's non-terminating by 12. Those decimals would continue going forever. So when we have an irrational number and we multiply it by anything else, it stays irrational. We also know that because this is a number we're trying to classify in the 8th grade, it has to be real, because every number we talk about in the 8th grade will be real. I'm just going to actually save myself some time and write real in every one of these boxes, because I know that every one of these numbers has to be real. The second part of the instructions asks us to circle the most specific set. If I tell you that a number is real, that means it can be any number in all of 8th grade. If I tell you a number is irrational, you know that there's a decimal value that never terminates and never repeats. So you get a better picture of what the number looks like when I tell you it's irrational, because I gave you more information with that. So irrational is the more specific set. Take a look at the front page of your notes. We drew that we have that picture from yesterday. I'm going to outline the real number box really quick. That's this whole box is real numbers. And then this box is irrational numbers. Notice that the irrational number box is smaller than the real number box. That's not a coincidence. The more specific you are, the more restraints you have on something, the smaller whatever you're talking about has to be. So the smaller picture is always going to be the most specific set. By most specific, we mean the smallest set from our picture. If we look at the square root of 30, a lot of you are going to take out your calculators, and that's amazing. You're typing in second, and then the button that says x squared, and then a square root symbol pops up, and you write 30, and then you hit enter. Now, if you are an online learner this year, your second button is in gold. Face-to-face learners this year, your second button is blue. But that should help you find the second button, online learners. When you evaluate the square root of 30, you find that it's equal to a decimal. And we learned yesterday that any square root that is equal to a decimal is irrational. That's because that decimal is non-terminating and non-repeating. Now, between real and irrational, which one is most specific? What tells us more about the number? That's irrational. Looking at 45 over 5, I see that this is a fraction, so immediately I already know it's rational. because all of fractions are rational. The next thing I need to make sure I'm doing is evaluating the fraction, though. That way I know I'm not overlooking something that might be a whole number. To evaluate the fraction, you divide the numerator, or the top, divided by, that's what this bar means, the bottom. So to evaluate 45 over 5, we have 45 divided by 5, which is actually equal to 9. Now 9 is a positive whole number, so it can go into the whole number set. If you were to look at your picture from yesterday, you notice that the whole number circle is inside of the integer circle. So any whole number is also an integer, which means to write all of the number sets that this 45 over 5 belongs to, I also have to include integer. The most specific set, or what tells me the most about the number, real tells me it's any number in 8th grade. Rational tells me it's a decimal that does stop or it does repeat. Integer tells me it's a positive whole number or a negative whole number or 0. Whole number tells me it's positive whole or 0. So this is the most specific set. The other way you can tell is by looking at your picture. My sets in question were real, rational, integer, and whole. The smallest bubble here is whole numbers. So the most specific set should be whole. And you guys are going to try the next examples on your own. I'm going to pause the video about right now and let you guys try those. Now I'm going to give you the answers. Negative square root of 64. Remember, if you're typing in your calculator, you have to use the negative key, not the minus key. That's by the decimal button. And then after you type in the square root of 64, you find that the negative square root of 64 is actually equal to negative 8. Negative 8 is an integer. The square root was a whole number, so it is also rational. The most specific set here is integer. 0 we know is a whole number by the definition of whole numbers, which means it also has to be an integer, which means it also has to be rational, and we know that all of our rational numbers are also real. The most specific set here, again, is whole. 50.75, this is a decimal, so you ask yourself two questions. Does it repeat? And there's no repeating bar, and there's no repeating pattern, so we know this does not repeat. Does it terminate? I can tell you the last number in this is 5, so we know this does terminate. Since the answer to one of our decimal questions is yes, we get to say that this is rational. I could not classify this into the integers because this is not a whole number. There's a decimal with numbers after that are not 0, which means this is also not a whole number. The most specific set, or the smallest set, would be rational then. I'm going to pause the video now and we're going to talk about some football scores and what some examples might look like. We probably talked about something like 6, 7, some probably crazy football scores, and then 0 if our team was really not that great. A number that always classifies these is whole numbers, because this includes 0 and positive counting numbers, positive whole numbers. So whole will always classify these things. But what else can I call a whole number? The whole number circle is inside of the integers, so whole numbers are also integers. The integer circle is inside of the rational number circle, so integers are also rational. And rational numbers are all real. irrational numbers, just for reference, are also real. So even though we're classifying football scores as whole numbers, we also are going to include integer, rational numbers, and real numbers in our answer. I'm going to say integer, rational, and real. Oop, you guys can't see that. Let's pause the video again and we'll talk about some prices of gas. You probably, around our area this time of year in 2020, gas prices are about $2.15 to $2.20. Some people are probably telling us that you can fill up your entire gas tank for about $30. This is a whole number. This is not a whole number. So, something that would classify the price of gas all of the time would not be a whole number. So whole number is not going to be my answer. But I do have decimals all of the time because I can make 30 into 30.0. So rational numbers will always describe the price of gas. Rational numbers are also real, so I'm going to include that in my answer. We're going to skip this one and this one because we've talked about it already. We're going to look at the very last two. Are all whole numbers positive? Let's think about what it means to be a whole number. You might look at your notes from yesterday. Whole numbers are positive whole numbers and zero. If you have $0, think about that. Do you owe me money? You don't, so your total is not negative. But also, if you have $0, do you have any money? No. So your total is also not positive. 0 is in between negative and positive. 0 is what we call neutral. So this statement is actually false because 0 is neutral. The remaining 3 lines, you guys can try that on your own. And that will be all of today's video. So I will stop that now.